Welcome back to Quadratic Functions. We went through the first page of notes, spent about 10 minutes talking about this, and you need to have those in order to get credit for this. You need to have my notes on that. We're going to kind of specialize in this formula for right now, so I'm going to jot it down up here. That's y equals a times x minus h squared plus k. And the theory is if we have a function in that form, we should know exactly what the graph looks like right away, because the vertex is at the most interesting value of x would be h, because when we square something, squaring 0 gives us the smallest value. So the vertex is at h. When x equals h, we get 0, the myvox. And when x is h, we get 0 squared 0 times a0 plus k, making y k. The vertex is at hk. Then a tells us how fast it's growing, as you're going to see as we move down the page a little bit. So here we have a vertex. I don't want to do 5. That one's for you. I'm going to rewrite this one as f of x equals negative x squared plus 3. So in this case, the myvox is 0. When x is 0, we get 0 plus 3. F of x, or y, is 3. So I'm looking at vertex 3, and this graph is upside down. So I'm looking for vertex 0, 3. So far so good, but the parabola should be upside down. So 0, 3, upside down, and that is our only choice, D. Number 8. Vertex, myvox is 4. When x is 4, y becomes the opposite of 0 squared, which is just 0, and our graph is upside down. So looking for 4, 0, an upside down parabola, and that is A. There's certainly more things to talk about when we talk about the growth rates changing. But in this section, describe the graph of the function and identify the vertex. Well, we're going to start with our base function, and we're going to say looks like y equals x squared, except, and we're going to preface all of these solutions with that. So this one looks like y equals x squared. This plus 8 is a post function, except it's up 8. Now for this one, I'm going to rewrite it as f of x is negative 1/4 x squared minus 6. Didn't have to put those parentheses. Those are extraneous. Just kind of trying to emphasize h is 0 in this case. So this one looks like x squared, except it's post function times 1/4. 1/4 as tall. That takes care of there. The next one, upside down. And this is post function subtracting, so we're subtracting from y. It would be down 6. So just touching, 1/4 is tall, upside down, down 6. Myvox is changed now. The myvox is 7. That's 7 to the right. So right 7. Standard growth, so I don't have to mention that, looks just like x squared, except it's to the right 7, and post function plus 2, up 2. And you're like, well, this is a really easy section. Well, it still is, but now we got a little bit of work to do because we're not in that good graphable form. So this is completing the square. Now, it's going to become completing the square. This is actually factorable. Factors of 64 that add up to 16, 8 and 8. So this is x plus 8 times x plus 8. So g of x is x plus 8 squared. So this one looks just like x squared, except the MyVox is 8. That's left 8. It's growing at the standard rate, and it's not up or down. There's no post-function addition. So this one looks just like g of x, or just like x squared, except it's left 8. Now completing the square. And you've seen this before. This becomes pretty critical for us again later in the year, actually into the second semester when we're talking about conic sections. This becomes a pretty important process for us. And we'll be doing it on these next 4 problems. So you may want to jump straight to 23, 25, 27 when you're working on this. Very important process for us. So we need to get this to look like that. I want the square on x completed. So what I'm going to do is I'm going to group my x squared plus 3x, leave a blank, put the plus 1/4 out here. F of x is that. Now what goes here? We take half of 3 and square it. And the reason behind that is kind of the whole reverse of foiling, and that can be explained, but I'm not going to do that here. But we take half of this term, 3 halves squared, and we put plus 9/4 there. Here's the most important part as far as, if someone's going to make a mistake, the most common mistake is we don't balance this out. I just invented this plus 9/4. Without the 9/4 there, this x squared plus 3x plus 1/4 is clearly that. But this is no longer equal to my original function. I've got to keep it equal. So what did I really do here? I just added 9/4. So I balance that by subtracting 9/4 out there. Oh, okay, now I see. It's kind of weird, but this is the same as that because these would cancel. But this becomes a perfect square. X plus 3/2 squared. You could FOIL it out and check it. That works every time if we do that correctly. And 1/4 minus 9/4 is minus 8/4, where we end up with f of x equals x plus 3/2 squared minus 2. And now I know everything about this graph. It looks just like x squared, except it is, the MyVox is 3/2, therefore it is left 3/2. And then when x is 3/2, y becomes 0 minus 2. Oh, it's down 2. Okay. Now, a little bit sneakier here because we have to deal with this negative first. We're going to factor out -1. We get x squared plus 4x, leave a blank, put the plus 1 out there. And clearly this is equal to that, negative x squared minus 4x plus 1. So what do? We take half of 4 and square it. That's 2 squared plus 4. But that was just kind of a figment of my imagination. It wasn't, this is not equal to this anymore. We have to balance. And understandable, people are going to balance this by saying, oh, we need to subtract 4 because we added 4, but I did not really add 4. If I distribute this through, I get negative x squared, check, minus 4x, check, minus 4, ooh, got to balance that, plus 4, cancels that minus 4, plus 1. And then f of x is -1 times x plus 2 squared, perfect square, plus 5. Looks just like x squared, except it's 2 to the left. MyVox is -2. it's host function multiplied by -1, so what was up is now down, so it's upside down. And then when we're done with that, we add 5 to the y value. We add 5 to y, so up 5. All right? Another problem like that, completing the square. You say, well, I can't factor 2 out. Oh, we can always factor out. Factor out a 2, I get x squared minus 1 divided by 2 minus 1/2 x, leave a blank, plus 1. Distribute, make sure we're still on board. 2x squared minus x plus 1, sure. I need half of 1/2. 1/2 divided by 2 is 1/4, and I need that squared. Half of this term is 1/4, squared is 1/16. And this will always go in as a plus here. Now, what did I really just do? I really just added 2/16. So this 2/16 does not work up here. Here's 2x squared minus x. When I distribute, the plus 1's good, but this 2/16 is not good. I need to subtract 2/16 or subtract 1/8 to balance it. Now this is a perfect square. Careful, since it's minus here, it's x minus square root of 1/16, 1/4. You may FOIL that if you're unsure of yourself to check. I'd get an x squared, I'd get a minus 1/4 x and another minus 1/4 x. For minus 2/4 or minus 1/2 x, I get a plus 1/16. 8/8 minus 1/8 plus 7/8. Graphable, instant in our head. The 2's a little bit sneaky. See how we handle that? So my Vox is 1/4. We are right 1/4. We are twice as tall. 2 times as tall. And we are up 7/8. If I was to be graphing this twice as tall, normally over 1 is up 1, over 1 would be up 2. Over 2 is normally up 4, so over 2 is up 8. Normally, in a regular old parabola, if I go over 3, I go up 9. Not this one, I go over 3 up 18. Okay, so really important section, and not just for quadratics. This works for all functions we're going to deal with. We have to get it in a good, nice, clean, graphable form, and then work from our parent function or our base function. In this case, y equals x squared. So there's a 13-minute video. Suspect perhaps going to take you maybe about that same amount of time. You might want to start with these while it's fresh to you. Hopefully you have all the notes in there so you receive full credit. Let me know what I can help with.